So in this video, we're gonna discuss about basic integration rules or formula. So first rule, we have integral of 0 with respect to x. So by getting this, you're gonna think about a function whose derivative is 0. So that is c, constant. So why c? Because if you get the derivative of c of a constant, it is equals to 0, which are 0 back to c is antiderivative or integration. Next, the second formula is formula for integral of a with respect to x. So the derivative of a function will be ax, and we'll add our integration of c plus c. So we get this if we derive ax, which derivative of ax is a, and derivative of c is 0. So we have an example here. Let's say we have 3 with respect of x. Put 3x, and let's add the integration of c. So remember, if you have a constant of 3, just add x. So another one is if you have integral of 4 dx, so 4x plus c. So next rule is important rule. It's the power rule. So it says that if we integrate x raised to n with respect to x, this is equal to x. So what you do is you add 1 in the exponent, then divide it by number, then you add c. So this formula is only valid if n is not equal to -1. So let's have our example here. Integral of x is to 2 with respect to x. So let's just add 1 to the exponent, so x3 over 3 plus c. So we can check this answer if this is correct. So if we take the derivative of this one, we get 3x squared over 3 plus 0, because the derivative of c is 0. So we'll just have x squared. So let's check from here. So another one, we have integral of x4 dx, which is equals to let's add 1 again in the exponent, equals to x raised to 5 over 5 plus c. And if we check again, the derivative of this will have 5x4 over 5. When we cancel out this, then 0, so this is equals to x4. Check our answer. So the fourth next rule says that if we have a constant multiplied by a function from x with respect to x, we can pull the constant out. So let's have a integral of f of x with respect to x. So let's have our example. So example, sub integral of 5x cubed with respect to x. So if we integrate this, so we'll pull out the constant 5, and then let's have x cubed dx. So we can do it by, well, and then have this way, pull out our constant and integrate x3 dx. We have x over 4 plus c, and or we can simplify this by 5 over 4 x4 plus c, and then we can check this if we get the derivative of 5 over 4 x4 plus c. So let's take our 5 over 4, and then the derivative of 4 x raised to 4 is 4x 3, and our c will be 0. So we have 5x3 here. So we can use another example here. I recommend you to use this easiest way. Let's have the integral of constant 4x raised to 3 with respect to x. You can just put the constant out and then add 1 by using the other formula. We can add 1 to the exponent and add 1 here also, and plus c, and then we can cancel out this, so we have x4 plus c. So lastly, we have our last formula. It says that if we integrate the sum or difference of two functions, f of x plus minus g of x with respect to x, this is simply just integral of f of x with respect to x plus minus integral of g of x with respect to x. So let's have our example. Let's say we're trying to integrate 2x plus 3 dx. So we can just integrate this by piece. Integral of 2x will be 2x2 over 2. This is a formula from this one, because you add 1 to the one, and then by using the other formula 3, we have 3x, and then don't forget the integration of c. So by simplifying, we can have x2 plus 3x integration of c. Next is we have a general integration formula, and we have 4 formula for general integration. First will be the power formula. Integral of u, which is our function, is to n du, will be equals to u n plus 1 or n plus 1, similar power formula, plus c, and this is only applicable if our n is not equal to -1. So if you have a -1, we can use the second formula, which is the integral of du, our function, over u. So this formula, we can say that the derivative or function of the denominator can be found in the numerator. So the derivative of du over u is ln absolute of u plus c. The third formula will be the exponential, to be integral of e u du, which is equals to integral of e u plus c, which is the same if you have a constant integral of au raised to u du is equals to a raised to u over ln of a ln a plus c. So these are our four formulas for the integration that we'll be using for our u substitution. So let's have our u substitution. Examples. So first, let's have integral of 4x x raised to 2 plus 5 cube dx. So first, we're gonna exchange the x variables to u variables. So we can have we can let our u be the x squared plus 5. So sometimes you can find your u inside the parentheses, which is x2 plus 5, or sometimes it will be x plus 1 or 1 plus x. So next, let's find our du, which can be found here. So we can, our derivative of u, which is x2, will be 2x, and it can be cancelled out here with our 4. So we can have 2x multiplied by dx. So we'll be solving this equation by using the dx. So we can divide this by 2x and du by 2x. We can cancel this out, so we have our du over 2x is equals to dx. So we're gonna replace this dx by du over 2x. So here we can have integral of 4x, and let's replace this by u. We can have u raised to 3 cube, and let's replace this dx by du over 2x. So we can cancel this out, and this one 4 over 2, so we can have 2 constant, or constant will be out. Integral of u cube du. So by using the power rule, have 2 times u 4 over 4 plus c. So 2 over 4 is equals to 1/2 u 4 plus c. So after this, so the last thing you will do is you're gonna replace the variable u with your value of x2 plus 5. So we can have this as 1/2 our u, which is x2 plus 5, x2 plus 5. Let's copy our exponent 4 plus c. So this will be our final answer. Next, let's have another one. Integral of x3 e with exponent of x raised to 4 dx. So what will be our u here? U or du. So if we make x raised to 3 our u, we can't get rid of x raised to 4. But if we have x raised to 4 our u, and the derivative of this will be 4x cubed, and we can get rid of x over 3, x raised to 3. So let's make our u be x4 and our du will be 4x raised to 3 times dx. So again, we'll use the same here. We'll isolate dx. So I recommend if you isolate dx, so you can't make a mistake, in later on. So du over 4x cubed equals to dx. So let's solve this. We have integral of x raised to 3 and e, and let's replace x4 as u, and dx as will be, so our dx will be du over 4x cubed. So we can cancel out our x cubed here and x cubed here, and then so our 4 will is on the denominator, so this will be a constant. You can take it out, is equivalent to 1/4 integral of eu du. So let's take the antiderivative of eu du, which is equals to eu plus c. We can use our general integration formulas here. So we have this will be equals to 1/4 eu plus c. This is u, and so let's replace ru with this equals to x raised to 4. So our answer will be 1/4 e raised to x over 4 x raised to 4 plus c. And this will be our final answer. And now we're on our last topic, integration by parts. So our formula for integration by part will be integral of u dv equals to uv minus integral of v du. So when we talk about integration by parts and we have this formula, so our basic problem or first problem will be how can we choose what function will represent the u. So I'll teach you a trick on how to choose the function that will represent letter u. So now the trick that I want to teach you is a technique about Liate. So what is Liate, no? So Liate is L stands for logarithmic, I stands for inverse trigonometric, A stands for algebraic, and theta means trigonometric, and E means exponential. So how do you use this Liate? So you can use this when you are given a function, function or a problem that consists of two functions. You have example, you have a logarithmic and algebraic function in one problem. So how do you choose your u by using Liate? So you can, as you can see, L comes first, I second, A third, trig fourth, and fifth exponential. So you can choose your u by following this. So example, if the function have logarithmic and algebraic, you can choose your u by following this. You have your logarithmic, so your logarithmic function will be your letter u. And other example, if you have a trigonometric and inverse trigonometric in one problem, so you can choose your u by this technique. The first function is inverse trigonometric, so you can choose inverse trigonometric as your u. So here we have example, integral of x sine x dx. So here x is our letter A, which is an algebraic, and our sine x here is our t, which is our trigonometric. So in here, we can use Liate to choose which function will represent letter u. So in Liate, the first one comes first is letter A, the algebraic, before the trigonometric. So we can represent our u here is equals to x, and our dv will be sine x dx. So what's the derivative of u du, which is x? So our derivative of u plus x is equals to the derivative of x, is equals to dx. And we'll still have to get our v. So to get this, you have to integrate our dv, get the integral of dv and sine x dx. So the integral of sine x dx is just negative cosine x. So you got to be familiar on how to get the differential and integral of the function, so you can you won't be confused, and so you won't struggle in integration by parts. So next, now that we have our u, du, and v, we can use this formula now. uv minus integral of v du. So we'll solve this by using this formula. So our u dv is equals to integral of x sine x dx is equals to our u is equals to x multiplied by our v, which is cosine x, negative cosine x, minus the integral of v du. So our v is negative cosine x dx, integral of negative cosine x dx. So we just follow this formula to solve and get the x sine dx. So next is integral of x sine x dx is equals to, let's multiply x multiplied by negative cosine x is just negative x cosine x. So we have 2 negative sign here, and we'll just multiply this, so we'll get positive, and integral of cosine x dx. So next we have our integral of x sine x dx is equals to negative x cosine x plus the integral of cosine x dx, which is sine x. And don't always forget your plus c. So this is the answer, the first example. Next we have our next problem here, which is x squared ln x dx. So we have two functions here, which is x squared, which is an algebraic, and ln x which is our ln x which is logarithmic. So next we'll find our u. So how do we find u? It's the same, we're still using the Liate on how to find our u. So we have here algebraic and logarithmic. So which comes first, algebraic or the logarithmic? So logarithmic comes first, so our logarithmic ln x will be our u ln x, and our integral of dv will be integral of x squared dx. So we need to still find our du, so we can use this formula of integration by parts. So our du is simply the derivative of ln x, which we know is 1 over x dx, and still we need to find our v, which is the integral of x squared dx. So how do we find it? So by using the power formula by exponent, we add plus 1 here, and same with the denominator 2 plus 1. So we'll have x cubed over 3. So now that we have our dv and v, we can use this formula. So let's just substitute our variables here in the formula. So we have integral of x squared ln x dx, which is equals to ru, which is ln x times x cubed over 3, which is our v here, and minus the integral of v du minus of integral of v, which is x cubed over 3 multiplied by r du, which is 1 over x dx. So before we integrate this part, we can simplify this problem. So integral of x squared ln x dx is equals to so by simplifying, we can multiply this, and we'll get x cubed ln x over 3, sorry, 3, this is 3 minus we can cancel out here our x and 3, so this will become 2, and we'll just have, or we can have 1 here, 1/3, so we can put 1/3 out. It's a constant, we have to put it outside the integral. integral of x cubed over multiply by 1 over x dx. So again, we can we can simplify this. We'll have x squared ln x dx equals to x3 ln x over 3 minus 1/3 multiplied by the integral of x cubed. This will be just x2 plus 1 over 2 plus 1. And next we'll have our x ln x dx equal to then we have x cube ln x over 3 minus we can multiply this. Our denominator 2 plus 1 is 3, so our denominator will now be 9, and 2 plus 1 is all 3, so it will be x raised to 3, and don't forget our plus c, and this will be our answer for integral of parts of this problem. Thank you.